Hello student, in previous class I discussed about the concept of cell and subcell. What is cell? How many types of subcell found? Next I have also covered the shape of orbital. I have covered the shape of s orbital. These are the s orbitals. This is 1s orbital, this is 2s orbital, this is 3s orbital. Next, I also covered the shape of p orbitals. There are five. There are three p orbitals: px, py, p, and pz. Here I have given the px orbital, py orbital, pz orbital. Each p orbital having two lobes. Next, I have also covered the nodal plane. What is nodal plane? Here I have given exact nodal plane for py orbital. Next, I have also give a diagram which clearly represent the three p orbital px, py, pz. Next, I have also covered the shape of d orbitals. There are five d orbitals: dxy, dyz, dzx, dx square minus y square, dz square. The 3D orbital, that is your dxy, dyj, dzx, present between the coordinate axis, while the dx square minus y square dz square orbital lies in the coordinate axis. Here I have given 5D orbital. This is your dxy, this is your dyz, this is said to be dxz, this is said to be dx square minus y square, this is said to be dz square. Next, I have also given some hints regarding about the p orbitals. There are seven p orbitals: p x y square minus z square, p y z square minus x square, p z x square minus y square, p x q, p y q, p z q, and the last is p x y z. Each orbital of p have eight lobes. Now, in this chapter, I will discuss a very important two or three mark. In exam, this always come. That is, what is the difference between orbit and orbitals? Orbit means you generally think about the cell. There are different types of cell, and we know that each cell are circular in shape. Next, the orbitals are three-dimensional space. Look at that. At first, I will discuss the first point. Orbit are circular. These are the different orbitals. This is your K cell. This is your K cell, L cell. Here I have given K cell, L cell, M cell. Like that, there are different orbitals are shown here for different atoms. But if you think about the orbitals, look at that. They are three-dimensional. This is your dx square minus y square. This is your dyz. This is your dzx. This is dxy. This is dz square. So the first point is your it is a circular path around the nucleus in which an electron revolves. In the other hand, if you think about the orbital it is a three-dimensional space around the nucleus where there is a maximum probability of finding electron. So here I can say that the second point is it has a circular shape. Already I have. Uh, Next is the shape of different are different. Yes, obviously here these are the shape of d orbitals. If you think about the s orbital, then it is spherical, symmetrical. Next, if you think about the p orbital, px look like this, py look like this, pz look like this. Similarly, the shape of f orbitals are very critical, so it is not easy to show here. In plus two level, it is sufficient. Generally, we think about the three important orbital s, p, d. So here I can say that for orbit we can say that it is a circular shape. And if you think about the orbital, then different orbital have different shape. So here we cannot write a single point like the orbit. The electrons revolves. The third point is the electron revolves around the nucleus in one plane. Obviously, If the shape of the we know that the shape of cell, that is your orbit, is your circular. Circular means it have two axis, x axis, another is your y axis. So the always we know that circle is present in a two dimensional space. So we know that plane is also belongs to two dimensional. So here we can say that the circle is present in a two dimensional plane. So here we can see that electron revolves around the nucleus in the circular path, means in one plane. But if you think about the electron revolves it revolves in an orbital in three-dimensional space. Generally, electron revolves in a three-dimensional space. Your two-dimensional space, that is your one plane. If you think about the orbit, the position and momentum of the electron can be determined. But if you think about the orbital position and momentum of the electron cannot be determined simultaneously. Your next fifth number point is in orbit, maximum number of electron can be found by 2n square rule. But we know that whether it is p orbital or d orbital or f orbital or s orbital, each orbital have a maximum 2 electrons. You can take any type of orbital, the capacity of that orbital must be 2. But if you think about the orbit, then different orbit have different capacity to acquire the electron. This can be determined by using the 2n square rule. Orbit do not have a directional character. Okay, orbit do not have directional character because it is circular. But if you think about the orbital, s orbital is your spherical symmetrical. So except s orbital, all the orbitals have directional character. Look at that, the p orbital. If you think about the px orbital, then its direction is towards the x-axis. If you think about the y orbital, its direction is towards the y-axis. If you think about z orbital, pz orbital, then the direction of the pz orbital is your z-axis. Px x direction, py y direction, pz z direction. So here we can say that orbits do not have directional character. But if you think about the orbital, except s orbital, all the orbitals have directional character. Again, I want to repeat, what is the difference between orbit and orbitals? Orbits is a circular path, here three-dimensional space. Next point, orbit, the orbit is a circular shape. This is also the similar point, but here the point one is different. It is a circular path around the nucleus in which electron revolves. The here you can say that it is the three-dimensional space around the nucleus where the maximum probability of electron finding electron is maximum. Second point, it is a circular space. It have different orbital have different space. Electron revolves in one plane, here three-dimensional plane, three-dimensional space. Momentum position can be determined for an orbit. Momentum and position cannot be determined for an orbital. Maximum number of electron for an orbit is calculated by 2n square rule, but here maximum number of 2 electron present in an orbital, and these 2 electron are found in opposite spinning. One is clockwise spinning, another is anti-clockwise spinning. Next, orbit do not have directional character, but except s orbital, all the orbital have directional character. This is important, 2 or 3 mark. Next, I move to the another very important concept, that is your Paul's exclusion principle. Before going to explain about the Paul's exclusion principle, I will give a general daily life example. Suppose select two person. Suppose select two student. One student name is, suppose that is your Pavitra. Another student name is suppose Mohan. Suppose I will take two student Pavitra. Another is your Mohan. You cannot say that the two students have same set of all the things. They may be different in any terms. If you think about the twins, No doubt twins are same, they are maximum things are similar to each other, but they are different in their name. Maybe they are different in their weight, maybe they are different in their class, anything they have different. You cannot find two such people which have the same thing. All things are same. All things means think about the structure of the body, personal work, official professional work, educational qualification, address, place, everything. If you think about everything, then no two such person you will get in the earth. There is no two person in the earth or in the planet. You can think about anything. Both having the same setup for everything. Everything means, again I want to repeat, everything means educational, professional, personal, structure, everything. You can take everything for the similarity. They may have slightly different. You may think about the twins. No doubt the twins are look like the same, but they are different in their in some parts. In some cases they are also different. Similarly, think about the electron around the nucleus in an atom. There are number of electrons present in the nucleus, around the nucleus. In case of oxygen, there are 8 electrons surrounded to the nucleus. So, if you think about the electrons, every electron, already we know that every electron have four set of quantum number. Four set of quantum number. Every electron have four quantum number set up. You cannot say that all the four quantum number are same for two electron. No, there must be different in their spin quantum number. If you think about two electron in a particular orbit, suppose I will think about the px orbital. There are two electron present in the px orbital. Here now we can say that this is your U1 E2. Here we cannot say that U1 E2 have the same four set of quantum number. You cannot say that the spin quantum number is same, because we know that in an orbital the two electrons are in opposite direction. Suppose U1 is your clockwise direction, that is your S is equal to plus R, then it is compulsory for E2 it spin in the anti-clockwise direction. That means it must have minus R. You cannot say that the value is your S is equal to plus R. So like the our society, the two electrons have do not same set of four set of quantum number. Look at that. Suppose I will think about the K cell. K cell have two number of electron. Suppose these two electron are said to be U1 and E2. If you think about the set of four quantum numbers, then I can write here, here n is equal to what? 1. For U1, it is 1. For E2, here n1 is, n is equal to 1. Because both the electrons are present in K cell. For K cell, we know that n is equal to 1. So you cannot say for E2 n is equal to, because both the two electrons are present in the same cell. So here I can say that U1, what is U1 is your for U1 n is equal to 1, for E2 n is equal to also 1. Since K cell have, remember, since K cell have one subcell, that is your S subcell. For S subcell, here we can write L is equal to 0. So for E1 and E2, both L is equal to 0. Yes or no? Next, suppose think about the magnetic quantum number. Magnetic quantum number indicate to the orbital. S subcell having the same thing, that is your S orbital. For S orbital, we know that m is equal to 0. For E1, m is equal to 0. For E2, m is equal to also 0. But if you think about the spin quantum number, since these two electrons are present in the s orbital, we know that in an orbital, maximum two electrons are present, and the two electrons are in opposite spin. Recently, I have seen this. So here I cannot say that both both for E1 and E2 the S value is same. Look at that. If I will take if for E1 is your plus R, then it is compulsory to take S is equal to minus half for E2. If you will take U for E1 S is equal to minus half, then it is compulsory to take E2. For E2 it is compulsory to take S is equal to, that is your plus half. Otherwise it cannot be possible, because we know that in an orbital to maximum two electrons are present and the two electrons are spin in opposite direction. Suppose suppose first electron spin in clockwise direction, then the second electron automatically spin in the anti-clockwise direction to maintain the stability of the atom. Otherwise, if both the two electrons are spin in the same direction, then there is a unstable in the atom. Atom cannot be stable. If atom cannot be stable, then molecule cannot be stable. If molecule cannot be stable, then substance obviously unstable. So here we can prove from this data, it is clearly proved that an orbital have a maximum two electron, because if you think about the two electron present in the K cell, the two electron have the different set of the two electron have different S value. One is your plus half, another is your minus half. There is no other value. That means for the two electron have the different quantum number. One is a plus half, another is minus half. So we cannot say that the other value is present. Other value can be found. That means two value represent two electron. So here we can say that therefore an orbital can have maximum two electron, and the two electron must spin in opposite spin. Clear? Now let me state what is Paul's exclusion principle. No two electron in an atom. We cannot find two electron. That means no two electron in atom can have the same value for all quantum number. That means no two electron have the same four quantum number value. There must be no doubt the three quantum number may be same, but the fourth quantum number, spin quantum number must be different. Suppose someone will take one electron from the K cell, and the second electron takes from the L cell. From the initially, from the beginning, n value is different. Look at that. For K cell, n value is equal to 1. For L cell, n is equal to 2. What may be the other quantum number? Principal quantum number is from the initial, it is different. So you cannot say that such type of two electron which having same four set of quantum number. There must be change of the spin quantum number. Look at that. In an orbital maximum, how many electrons are present? Two electrons. If you think about the three electron, then the third number electron is excluded from the orbital. Since the Paul's exclusion principle is based on the maximum two electron, it cannot think about the three electron in an orbital. That's why Paul's exclusion principle is said to be Paul's. Sorry, that's why Paul principle is termed as Paul's exclusion principle, because it excluded the third electron. So here I can write Paul's exclusion principle is excluded the third number electron. Here I have written, look at that. Why this principle is called Paul's exclusion principle? Because the probability of accommodating more than two electron in an orbital is excluded. So this principle means Paul's principle is called Paul's exclusion principle. From the word excluded, here exclusion is written. So we can give the other statement. First, no two electron in an atom can have a same value for all the quantum number. The second statement will also another, that is your an orbital can contain maximum two electron. This can be verified Paul's exclusion principle. So here we can take this sentence as a second principle, second statement of Paul's exclusion principle. What is the second principle? What is the second statement for the Paul's exclusion principle? An orbital can contain a maximum of two electrons. This is the second statement. Now move to the conclusion. Here we can say that each orbital, you can take any type of orbital. You can take an orbital from P sub cell. You can take an orbital from D sub cell or F sub cell or S sub cell. Yeah, every orbital have maximum 2 electrons. Suppose we know the number of orbital present in a subcell. Then you can easily calculate the total number of electron present in the subcell, because each orbital carry 2 electron. Then multiply the number of orbital with 2. You can easily find the total number of electron in the subcell. Let me conclude. Look at that. Here I have given S subcell. We know that the number of orbital present in S subcell is your 1. Each orbital contain 2 electron. So here the total electron is your what? 1 into 2, that is your 2. Similarly, think about the p orbital. For p orbital, we know that. Listen. If you think about the p orbital having maximum three orbitals, px, py, pz. Each orbital carry 2 electron. That means here I can write 3 into 2 is equal to 6. Here 3 is the number of orbital, 2 is the maximum electron present in one orbital. Next, for D subcell, D have 5 orbitals. Each orbital carry 2 electrons. So here you can write 5 into 2 is equal to 10. That means D subcell having 10 electron. Similarly, think about the F subcell. F subcell having 7 number of orbitals. Each orbital carry 2 electrons. So here you can write 7 into 2, that is your 14. That means F subcell having 14 electron. Look at that. Suppose think about the n square and 2n square. Let me explain. We clearly know that the maximum number of orbital in each cell is your n square. Let me explain. Let me explain. Look at that. Suppose think about the k cell. K cell having n value is your 1. N value is your 1, and it have one orbital, that is your s. One subcell, that means it have one orbital. Here the number of orbital is your 1. That means let take another, then I will conclude. Suppose think about L cell. Here n is equal to 2. Number of subcell is your s, p. S having one orbital, p having 3. That means 1 plus 3, that is your 4. Number of orbital is your 4. Think about the is equal to what? 3. It have 3 orbital s, p, d. Orbital d having 5. Total is your how much? 9. Let me explain. For k cell, n is equal to 1, and the number of orbital is your also 1. That means here I can write 1 square. That means n square. Similarly, for L cell, n is equal to how much? 2. The number of orbital is your 4. Take n square. N square means 2 square, 2 square, that is your 4. 4 means which is equal to the number of orbital. Similarly, for M cell, n is equal to 3. Number of orbital is your here given 9. 9 orbitals are present. 9 means 3 square. So here I can write 3 square. 3 square means it is related to the n square. So here I can say that if you think about the number of orbital in each cell, that must be n square. Here we know that one orbital having 2 electron. One orbiting how much electron? 2 electron. If an cell having n square orbital, that means the total electron is your how much? 2 into n square. Again I want to repeat. If a cell having n square orbital, each orbital having 2 electron, that means the total electron present in the total orbital, that is your in one cell is equal to how much? 2 into n square. So remember this 2n square rule. So here I can prove that the maximum number of electron in a cell is calculated by 2n square. Let me now it is verified. If already we know that maximum number of orbital in a cell is your n square. Each orbital having 2 electron. Now multiply 2 into n square is the total number of electron in the cell. So this is your said to be 2n square rule. Now here I verified. This is all about your Paul's exclusion principle. Let me explain and very important that above principle. It carry 3 mark or sometimes it also come to mark. State and explain above principle. What is above principle? Let me show something. Look at that. Don't think about the diagram. Only remember the number of subcell present in each cell. Think about the cell, first cell, that is your n is equal to 1. For n is equal to 1 means that is your thing about k cell. It have one orbital, that is your s orbital, and it is denoted as 1s. Am I correct? Think about the, let me write. I want to write. Suppose think about the first cell, that is your n is equal to 1, that is your k cell. Here n k cell having one orbital and it is denoted as 1s. Similarly, think about n is equal to 2. Here two orbital. One is your s, another is your p. They are distinguished by writing the two the in the left side of the orbital 2s 2p. Why here 1s, here 2s. Similarly, think about n is equal to 3. That is your 3s, 3p, 3d. Similar thing about the n is equal to 4. Here we can write 4s, 4p, 4d, 4f. Similar thing about n is equal to 5, 5s, 5p, 5d, 5f. You cannot take also other orbitals, but here this is sufficient because no such type of element will found which will occur in the g orbital. So write only this term up to f. If n is equal to 6, then you can write 6s, 6p, 6d, 6f. If n is equal to 7, you can write 7s, 7p, 7d, 7f. If you like that, you can think about n is equal to 8, 8s, 8p, 8d, 8f. You can write like this up to infinite. N is equal to 9, n is equal to 10, like this. Look at that. Here, already we know that the electrons present around the nucleus. This is the nucleus. The electrons are present around the nucleus. This is your cell. Already in the 9th, 10th class, we already know. Already we knew about the electronic configuration. Electronic configuration according to the cell. For K cell, you can give 2 electrons. For L cell, you can give 8 electrons. For M cell, you can give that is your 18 electron. Follow 2n square rule. Follow 2n square rule, then you can find. For N cell, you can write 2 into, that is your 4 square, that is your 2 into 16, that is your 32 electrons. The N cell have a maximum 32 electron. After that, it will not receive. Already you know about the electronic configuration in terms of a cell. Now in plus 2, I will teach you the electronic configuration in terms of subcell. How you will write the electronic configuration here. Let me explain. There are different orbitals are present. At first I want to teach you to write the electronic configuration in subcell. Then I will give the electronic configuration in the orbital also. Let me explain the electronic configuration in terms of subcell. Look at that. There are different subcells. I listed here. There will be questions. There will be a question how you will fill the electron. Here we know that S having maximum 2 electron, P subcell having 6 electron, D subcell having 10 electron, F subcell having 14 electron. Then a question will come in your mind how you will fill the electron in the subcell. Someone suppose think about it first give 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 5. Like no, this cannot be possible. It follows a certain rule that is your said to be above principle. It follows a certain rule that is your said to be above principle. There are two rules in above principle. Above principle said that if an orbital, listen, if an orbital having minimum energy, having low energy, the lowest orbital, lowest energy of an the orbital which having the lowest energy that filled fast. According to above principle, the electrons are filled in various orbitals of an atom in the increasing order of their energy. That means orbital of the lower energy filled fast before those of higher energy. That means again I want to repeat. At first, give the electron to the orbital which having lowest energy. Then a question will come in our mind: how you will determine the energy of each orbital? Here we cannot search orbital having the low energy. It is very difficult. So the scientists above, they have give two rules. Rule number one for the calculation of energy, which orbital having low energy. There are two rule. Rule one, rule two. By using these two rule, you can determine which orbital having low energy. Let me explain the first rule. These two rules are said to be N plus L rule or Bohr-Buri rules. Very important. It is your what is this rule? That is your N plus L rule or Bohr-Buri's rule. Let me explain the rule one. What is the rule one? According to the rule one, at first suppose I have given 3s orbital, 4s orbital. Among the two orbital, our target to prove which orbital having which orbital having low energy. This can be proved by calculating the n plus L value. First rule says that if an orbital having more n plus L value, that means that orbital having more energy. Among I have taken two orbital here 3s and 4s orbital. If I will find out the n plus L value of each orbital, and I will verify which orbital having maximum n plus L value, higher n plus L value, then I can say that that orbital having high energy obviously. Let me explain. Here 3s orbital is one given, another is a 4s orbital. Already we know that if 3s orbital is given, you can easily find out the principal quantum number and azimuthal quantum number. Here n means what? Principal quantum number. L means here what? Azimuthal quantum number. Let me so 3s is here given. 3 means here principal quantum number, that is your n is equal to 3. S means L is equal to, that is your small L is your how much? 0. So here we can find that n plus L value is your how much? 3 plus 0, that is your 3. Now find out the n plus L value for 4s. Look at that, 4s is given. That means n is equal to 4. For s, L value is your 0. Now find out the L plus L value, n plus L value. Here we can write 4 plus 0, that is your 4. If you think about the n plus L value of 3s and 4s, then look at that, n plus L value for 3s is your 3. N plus L value for 4s is your 4. That means 4 is greater than 3. That means here we can say that n plus L value of 4s is greater than 3s. Clear? That means energy of 4s is greater than 3s. That means 3s filled fast. 3s filled fast. According to this rule, 3s filled fast. Then the next electron will go to the 4s. At first fill the 3s because it have a low n plus L value and low energy. According to the above principle, the first rule says that the orbital which having low n plus L value having low energy and it will fill fast. Let's suppose take another example. Suppose I will take a thing about 1s and another I will take suppose 2p. How will you determine which orbital having maximum energy and which orbital having low energy? That is your highest energy, another is your low energy. First, find out the n value for 1s. N value is your 1. Your 1 is written, so n is equal to 1. For s, L value is equal to 0. Now find n plus L value. N plus L value plus for 1s is equal to 1 plus 0, that is your 1. Think about 2p. For 2p, n is equal to how much? 2. P for p value L is equal to 1. Now find n plus L value, that is your 2 plus 1 is your 3. Now let me explain. If you think about n plus L value of 1s and 2p, here I can write n plus L value of 1s is your what? Smaller than n plus L value of 2p, that is your here n plus L value of 2p means 3, here n plus L value of 1 is 1. 1 smaller than 3, obviously. So now here I can say that energy of 1s is smaller than energy of 2p. So here we can say that 1s will fill fast, then 2p will be fill fast. Like that you can also think about the another orbital. Suppose I want to think 1 2s, another is your 3d. Which orbital having maximum energy and which having low energy? Here n is equal to 2, here n is equal, L is equal to 0, here n is equal to 3, L is equal to how much? 2. Now find n plus n value for 2s is equal 2 plus 0, that is your 2. N plus L value for 3d, that is your 3 plus 2, that is your 5. For 2s, n plus L value is your 2, 3d, 5. That means n plus L value of 2s smaller than n plus L value of 3d. Are you getting my point? That means energy of 2s smaller than energy of 3d. So the electron will fill fast in the 2s then 3d. Okay, like that you will find the n plus value of all orbital, but a certain problem will come. Let me explain why the second rule is necessary. If you will put the first rule to all, if you apply the first rule to all orbital, then there will be a problem will create. Think about 2p and 3s. Look at that. For 2p, n is equal to 2. For p, L value is your 1. This is your L value. Now find out the n plus L value. N plus L value is your how much? 2 plus 1. Total is your 3. Now think about the 3s orbital. Look at that. If you think about the 3s orbital, here 3 is written. That means n value is your 3. L value is your how much? 0. For s orbital, L value is your 0. Now find out the n plus L value. N plus L value is your how much? 3 plus 0, that is your 3. Look at that. Here a problem is happened. What is the problem? For 2p orbital, n plus L value is your 3. For 3s orbital, n plus L value is also 3. Yes or no? This is your 3, this is your also 3. Both the orbitals having the same n plus L value. Then a problem is created here. How will you solve? You follow the second rule. Second rule says that if two orbital having the same n plus L value, then what you will do? You choose the n value. You follow the second step, that is you choose the find the n value. Remember, the orbital which having low n value, that orbital is said to be having less energy. Again, I want to say that suppose two orbital having same n plus L value, then go to the n value. Then In the second step, go to the n value. Which orbital having low n plus low n value, that orbital is said to be having low energy. Look at that. Here n plus l value is your 3. Here also n plus l value is 3. But here n value is your what? That is your 2. Here n value is your what? 3. Let me explain. For 2p orbital, n value is your 2. For 3s orbital, n value is your 3. So according to the second rule, 2p orbital having low energy. So here we can say that 2p is filled fast than 3s. So what is the second rule? If two orbital have the same n plus l value, then the orbital with the lower value of n has the lower energy and is filled fast. Take second example there for your better understanding. Suppose think about the think about the 2p orbital, and here already I have given 2p orbital, another is a 3s orbital. Let me explain another example. Suppose think about the 4p orbital, another is a 5s orbital. Apply the first rule first. Here n is equal to what? 4. Here L is equal to what? 1. For 5s, here n is equal to 5, L is equal to 0. Now find the n plus L rule. N is equal to 4 plus 1, that is your 5. Here n plus L is your what? 5 plus 0, that is your 5. Both orbital, that means 4p and 5s, having the same n plus L value. Here 5, here also 5. But if you apply the second rule, then find the n value, principal quantum number value. 4p have the principal quantum number, that is your 4. 5s have the principal quantum number, that is your 5. As per the second rule, the orbital which is having low n value, that is considered as having low energy. So here 4 is smaller than 5. That means the 4p having low n plus l value as compared to 5s. So 4p having less energy as compared to 5s. So 4p filled fast than 5s. By applying the rule, let me explain. By applying the rule, you can find the and you can compare each orbital. You can compare each orbital, which orbital having low energy, which orbital having high energy. You clear you by using these two rules, you have no problem to go or find out which orbital having low energy and which having more energy. There are different orbitals. Already I have shown you these are the various types of soft cells present here. Look at that. Here you can think about the different soft cells. If you apply the n plus L rule, remember, if you apply the n plus L rule, then you will find this order. Remember an important point. If you think about the p orbitals, there was a problem. If you think about the p orbitals, that means you are talking about the p subcell. If you think about the d orbitals, that means it is combinedly represent to the d subcell. Here I have written the subcells, but the principle is said about the orbital. No. Look at that. Here orbitals is written. That means it clearly indicate about the subcell. Think about the subcell. Clear? If you apply the above principle to each subcell, then you will find this order. 1s having the lowest energy, then 2s is greater than 1s, Like that 2s smaller than 2p. Again I want to repeat, 1s smaller than 2s, 2s smaller than 2p, 2p smaller than 3s, 3s smaller than 3p, 3p smaller than 4s, 4s smaller than 3d, 3d smaller than 5 4p. Like that you can remember this order. Or otherwise it is very easy to remember by following this diagram. It is easy to follow this diagram. If you will follow this diagram, then you easily remember the sequence, that increasing order of the energy of the subcell. If you know clearly about the increasing order, then you easily fill the electron. Remember, above means building up, that is your filling of electron in the orbitals. Let me draw the diagram. Look at that. How will you draw and how you will remember the diagram? At first, write this n is equal to 1. Write in a row. Let me explain again here. At first, write n is equal to 1. N having 1 cell, that subcell 1s. N is equal to 2. You can write 2s. Next, give gap to p. N is equal to 3. Don't think that it is very critical. It is very easy to remember. You should write in particular row and particular column. If n is equal to 3, then you can write 3s right below of the 2s. Next, write 3p here. Next, give space, then write 3d. Suppose n is equal to 4, you can write here 4s, 4p, 4d, 4, give space, write on 4s. Next, n is equal to 5, write on 5s, 5p, 5d, 5f. N is equal to 6, write on 6s, 6p, 6d, 6f. How can you write the diagram? N is equal to 7, 7s, 7p, 7d, 7f. 9, n is equal to 8, 8s, 8p, 8d, 8f. Then how will you draw? Look, start from 1s. Give an arrow mark like this. Start from 1s. Clear? Then touch the 2n orbit. That is your n is equal to 2. And give an arrow mark. Clear? Next, give the 2s. They will draw like parallel line. Start from this position, cross to the 2s, go to the 3. 1, 2, 2, 3. Next, go to the 2p, 2p, 3s, 4. Okay, give the arrow mark. How will you check? Look at that. Next, give an arrow mark like this. Come across to the 3p, then go to the 4s, then go to the 5. Look at that. Here 3p, 4, 3, 4, 5. Next, start from the 3d, go like this. 3, 4, 5. Next, go to the 6. Okay, give arrow mark 3, 4, 5, 6. Next, give the arrow mark, start from 4d, comes from here. Go to the 4d, next 5p, next 6s, next 7. Give the arrow mark. Next, give the arrow mark from the 4f. 4f, 5, 6, 7, 8. Okay. Next, go to the 5pf, 5f, 6, 7, 8. Then you can give also 9. Here I have not written. Uh, Next, go to the 6f, 7, 8. Give an arrow mark. 7, 8. Here also give arrow mark. This is the diagram. Then how will you go through the diagram? First, go to the first arrow mark. This is the first arrow mark. This is the what? First arrow mark. Already we know that the arrow mark when some arrow mark is given, suppose the arrow mark is given, then you follow like from this ending to this ending, and you will go like this direction. Suppose a direction is given like this, you will start your journey from this position to this position, then you will turn a then you will make a turn and go like this direction. Suppose a way is given here, a way is given like this. Suppose an arrow mark is given like this. Suppose you start your journey from this position to this position. When you will see such type of arrow mark, then you will move like this. The arrow mark indicate the way in which we will go. Think about the first arrow mark. This is your first arrow mark. It start from this position, then it go like this. If you will go from this position to this position in this direction, then you will find only one orbital, that is your 1s. So at first think about 1s which having the lowest energy, which having lower energy, that is your 1s. Next move to the second arrow mark. You will start your journey from, then go like this. Here we will meet the 2s. So you can write 1s smaller than 2s. So in the second row also one orbit or subcell is present, that is your 2s. Next thing about the third arrow mark. You will start your journey from this position. Go forward. Then you will find 2p. That means here you can write 2s smaller than 2p. Next again move to the forward. Then here we will find 3s. Right, 3s here. Next move to the 4. Here no orbital is present. Third arrow mark is now completed. Next move to the fourth arrow mark. Start your journey from this. Then you will go like this. 3p will come. So here I can write 3p. Next move to the another orbital. Here 4s will come. So here we can write 4s. That means 3p is smaller than 4s. Next, you will move to next. No orbital is found. N is equal to 5 is given. It is not an orbital. Next, follow the next arrow mark. This is the next arrow mark. Start your journey from. If you will go in this way, then 3D will come. So here we can write. Here you can write. Look at that. Here you can write 3D. After 4s you can write 3D. Next go through 4p. Next you will find 5s. Then go to the next arrow mark. Start your journey from this position. Here 40 will come first. Then you will move forward. Then you will find 5p. Then you can write here 5p. Next you can write 5p smaller than, that is your 6s. Next move to this arrow mark. Then you will find 4f. Next you will move to the 5d. Next what will come? 6p. Think about this arrow mark. This arrow mark. Next you will think about the what? 7s. Clear? That is your 7s. Next move to this arrow mark. You will find 5f. Next you will find 6d. Next you will move to the 7p. Next you will move to the what? 8s. Clear? Already this ray complete. Now come to this ray. Move. Think about next. That is your 6f. Okay. Next that is your 6f. Next is your what? 7d. Next move to the 8p. Then go to the this ray. Then your 7f will come. You can write 7f. Next you can write 8d, and the last is your you can write 8f. Thank you again everybody for watching the video. Namaste.